Yeah, so let's start with today's session. So today is week 9 of this NPTEL GATE live sessions, and the topic for today is stress analysis. Okay. So first, before starting the class, I'll tell you what I'm going to discuss in this class. So first, the problems related to Truss from different GATE exams. So GATE 2016, GATE 2019, GATE 2016 again, Gate 2018. So you are seeing that we are getting so many problems from this trust topic, although they are like looking like very difficult, but they are very easy to solve. We'll see. Okay, and they are coming a lot these years, like starting from 2016, 2019, 2020. Every year almost we have one or two problems from this topic. Problems are very simple. Okay, so let's discuss. So first, we will discuss this problem from GATE 2016, set 1, question number 33. So in this question, there's a plain truss with applied loads. So you can see a truss with a lot of members here, and there are different loads at different nodes. Okay. So we are asked that the members which do not carry any force. So they want to know the members which do not carry any force. So the members which do not carry any force are known as zero force members. You must have heard about these zero force members in your classroom also, and also I've discussed this in some previous class, but let us revise how to find the zero force members, because you'll see in gate exam this type of question comes a lot. So zero force member is a very important topic for this truss analysis. Okay, so how to find the zero force member? So directly I'll tell you, if you are given a trust with a lot of members, how do you identify the members which do not carry any forces, which are known as zero force members? So it's a very simple process, two-step process. Okay, just follow these two steps and you'll get to know which are the zero force member in a given truss. Okay, so the step one is we have to set up a coordinate system at the joint having maximum three connected members. So if we are given a truss, so we have to find the joints which have maximum three connected members. So we will start. So for example, this F joint has three connected members, right? FG, FE and FT. We'll not go first to this joint T. Why? Because it has more than three connected members. So if a truss is given to you, the first step is you'll identify the joint which has maximum three connected members. Okay, so the step one is clear, I hope. So we have to set up a coordinate system at the joint which have maximum three connected members. Okay, the second step is if only one force is acting in x and y direction, then the force is zero and corresponding member is a zero force member. For example, suppose this is a joint. So I'll make this is a joint. Let's say O, and let's leave it. So this is a joint which has maximum three connected members. So first of all, we will set up a coordinate system. That is the step one. So we will set up a coordinate system here. Coordinate system means simple x and y coordinate we'll make like this. So it's x and it is y. Okay, simple. The second step is we will name these forces here. So let us mark forces here. Let us name this force as P, this force as Q, and this force as R. Okay, first step is setting up the coordinate system. We have set up and then we have named the different forces. Now, for this joint O, we will see the number of forces in x direction. So number of forces in x direction are 2. Which are they? R and P. Okay, so since there are two forces in x direction, it means that in order to satisfy the horizontal equilibrium, these two forces must be balancing each other. So they are there to balance each other. Now we will see the number of forces in y direction. So how many forces are there in y direction? This P and this force R is not having any component in y direction. Why? Because it is totally in the x direction. But this force Q has one component in y direction also. Suppose if I'll call it theta, so Q sine theta is in y direction. I hope you agree. The sine component of this Q force is in y direction, and cos component of this q force is in x direction, right? So the number of forces in y direction is only one. Okay, whenever the component so in this force, the component of force q in y direction, so the number of force in y direction is only one, and there is no other force in y direction to balance this force q, right? Other than this q sine theta, there is no other force in y direction. But in order to satisfy the vertical equilibrium, this force q must be balanced. Okay, so this means that this q is 0, because only in that case the the vertical equilibrium will be balanced. Okay, but in question that in the given question, you don't have to worry about all these things, balancing the equilibrium and all. You will just set up the coordinate system, step 1, and step 2 is number of forces in x direction and number of forces in y direction. If the number of force in any of this two direction is 1, then that force is 0. So simple, in this case, the force Q is 0. And this member, let us name it as OM. So this OM member is a zero force member. Let us see how will we apply this thing in the given question. So the first step is we will identify the joints which has maximum 3 connected members. So there are a lot of joints in this truss. So let us start with just this joint F. This joint F has only 3 connected members, so we can choose this joint. The second step is to set up a coordinate system, or if, like after some time, after a lot of some practice, you don't need to set up this coordinate system as well. So we'll set up a coordinate system like this: one and other axis perpendicular to each other, so this one x and this one y. Okay, so we can name the forces as well. Let's call it as p. I'll zoom it a little bit. Let's call it as Q, and let's call it this force is R. Okay. So how many forces are there in X direction? There are two forces, right? So P and R are balancing each other. But there is only one force in the vertical direction, that is some theta component of this force Q. Other than this, there is no other force in the y direction. This means that this force Q must be 0. Okay, so this is the way to do it, but you don't have to draw this coordinate system every time. You can just see that if there are maximum three connected members, then this member must be a zero force member. Okay, the third member must be a zero force member. Only one condition: if there would have been if any external force would be acting, anything, let's p force, then in that case this won't be a zero force member, then this ft member will have some force. But if there is no external force and there are three connected members, then a third member will always be a zero force member. Okay, you don't even have to draw the coordinate system. Now, which other joint? So we can analyze some other joints in this way only. Please stop me if you have any question. Okay, please stop me. So now after F, let us take up any joint. Let us take this joint T. Okay, why I have taken T now? Because T has now three connected members only. Because why? Because ft member, we know that it is a zero force member, so we can neglect it from the analysis. So this joint T has three connected members, so it qualifies for our case. So we can take this joint T. This ET and TS are in the same line, so we can say that this member TG is a zero force member using the same concept. Okay, now we have identified this joint. Any other joint? You can take up any joint. Can we take S joint? No, we cannot at this stage, because S has more than three members connected to it. Let us take joint H now. H has three connected members, and the first two, that is GH and HJ, are in same horizontal line. Therefore, and there is no external load acting on H. Therefore, we can say that this member is a zero force member. Right? Any other joint we can take? Yeah. Let's see joint number K. Joint number K, in joint K also, the members JK and KL are in the horizontal, are in the same line. and the member KV is the only member which is coming out of it, but we cannot say anything about this member VK. Why? Because there is an external load acting on it. So this thing is valid only when there is no external load acting on the joint. Okay, so please note these points. Now we cannot take joint K also, we cannot take joint J also because it has more than three members. We cannot take R also, it has more than three connected members. We cannot take Q also, not L, not P also. And yeah, we can take M now. We can take M. In member for joint M, we have two members LM and MN which are in the same horizontal line, and the other member MP is coming out of it, and there is no external load applied at M. So we can say for member MP that it is a zero force member, right? So MP is also a zero force member. Now we can choose this joint P also. Why? Because now P also has only three connected members. Because MP has now become a zero force member, we can neglect it. So for joint P, if we analyze joint number P, we can see that QP and PN are in the same horizontal line, and member PL is coming out of it, and there is no external load applied at P. Therefore, we can conclude that this member LP is a zero force member. Okay, other than that we cannot comment anything about zero force member in this truss. So here we only have to find the options are given, uh, A, B, C, D, and we have five members in each option. So let's see option number A. The zero force member according to our analysis is FT, GT, HU, LP, and MP. So all these options are in this option number A, right? So this is our answer for this case. It is a 2 marks question, but see, it's very easy to find. Okay, if you know that how to find the zero force member, it looks like a very complicated problem, but it's very easy. You see, is there any problem in this thing? Zero force members? Any questions? Is it fine? Can I proceed? Can I proceed to the next question now? Okay. Next question is also, see, this question came in 2016. Now 2019, same similar question, very similar question. Okay, so can you try to find out zero force member in this case? Okay, so you can also try with me. Okay, using the same concept. So we have to choose the joints which has maximum three connected members starting from and which do not have any external load acting on it. Okay, so we cannot take joint E although it has three connected members because there might be some reaction here. So which we will consider as the external load, so we cannot take joint E. Then we can take joint number G because G has three connected members, out of which EG and GI are in the same horizontal line, and there is no external load on G as well. So we can say that GF is a zero force member. Now GF is gone, so we can take joint F as well. In joint F, E, F, and FG are in the same horizontal line, and Fi is coming out of it, and there is no external load acting at F. So we can say that this is also a zero force member. Other than that, we cannot take I, we cannot take H, we cannot take J also, we cannot take K, we cannot take L, M, P also, Q also, R also at this stage. Let's see this S. So S has do not have any external load acting on it, and it has only three connected members, which in out of which two are in the same line. So we can say that it is a zero force member, SR. Now R also we can take because now SR has become a zero force member. So R has only three members connected to it, out of which two are in the same horizontal line. So we can say that PR is also zero force member. Very simple, right? Very simple question. I guess a 2 mark question. I'm not very sure, but very simple question. So in this question also we have to we were asked that which of the following options contain only zero force members in the truss. So out of all these options, I think option number D is right, because we have, remember, FG as a zero force member, FI as a zero force member, RS as a zero force member, and PR as a zero force member, right? So option number D is right. I hope it's very simple to understand. There should not be any problem. But if even a slightest doubt you have, you can ask me. Okay. So one condition, three members maximum should be connected. Another condition, no external load should be acting. Third condition, at least two members should be on the same horizontal line. Okay, just three conditions you have to see, and you can solve any problem of zero force member. Okay. Now this zero force member, other there are many questions of this concept, so you can search for these gate questions related to this zero force member and you can practice. Okay. Now yeah, now after this we can take another question. Very simple question again, from GATE 2016 set 1. So see, in GATE 2016 set 1 we have two questions from trusses. So trusses are really important. Okay, so this truss is also looking like very complicated, but you will see it's a very simple question. Okay, consider the plain truss which is loaded with P. So it's a truss which has external load P acting at joint G. Okay, let the horizontal and vertical reaction at the joint B be HB and VB. So this is joint B, I guess. Yeah, this is joint B. So vertical reaction as VB and horizontal reaction as HB. Right. Another thing is yeah, and VC be the vertical reaction at joint C. VC be the vertical reaction at joint C.
Okay.
Will there be any horizontal reaction at joint C? No. Why? Because C is a roller support. Roller support does not has any horizontal reaction. Was a hinge support, therefore it has both HB and VB. So these small things you have to keep in mind. In this question, they are asking which one of the following sets give the correct value of VB, HB, and VC. So they are asking the value of VB, HB, and VC. Very simple question. When we are asked to find the reactions in a determinate problem or determinate stress, then we can simply use the equilibrium equation to find the answer. So let us do it here only. So the first equilibrium equation, so what are the equilibrium equations we have? Summation of vertical force equal to 0, summation of horizontal force equal to 0, and summation of moment at a point 0. So these are all the possible equilibrium equations we have, right? So we will use these equilibrium equation and we'll get our answer very very easily. So the first equation, let us see, summation of force in vertical direction 0. So what are all the forces in the vertical direction? If you see in this truss, in the vertical direction we have VB. Let's consider the upward force as positive. So VB plus, we also have VC here. And we also have P in the vertical direction, but it is in the downward direction. So we will take it as minus P. And so total force in the, so other than these three, we do not have any vertical force in this truss, right? So we will see, take it as 0. So we, from this we get the equation as VB plus VC equal to P. So this is the first equation we get, right? The second thing is we will use we will use this condition now. The summation of moment at any point should be 0. So we have this equation in which we have VB plus VC. If we get to know VC, then we can find VB as well, right? So we will use this equation, that summation of moment about this point B to be 0. So what are all the forces and how to find the moment? So we will use summation of moment about point B 0. we can take this also, we can take moment of about point C also 0, but when if we'll take the moment about B to be 0, we'll easily find VC, because only unknown force will be VC. Okay, so if we take a moment about B, so what are all the forces? The thing will be how to find the moment: VC multiplied by distance, force multiplied by distance. So what is the distance between this point B and VC? It is 2L. What is the other force which is acting? P. So and also the direction, if we say, if we consider clockwise direction as positive and anti-clockwise moment as negative. So if you will see from this point B, this force VC is trying to rotate this point B in the which direction? Anti-clockwise direction. VC is trying to rotate point. Consider a stick which is stick at this stuck at this point B, and it is here. So this force VC is trying to rotate this in anti-clockwise direction. So let us consider anti-clockwise as negative. Okay, so we'll put minus sign here. The another thing is force P is here. So force P is the what is the moment due to force P? Moment will be force multiplied by distance. Distance between this force P and this point B is again 2L. Okay, so we'll take 2L. Another thing is, what should be the direction here? So this force P is trying to rotate this point B in clockwise direction, right? This force P is trying to rotate this point B in clockwise direction. Therefore, plus we can we'll mark plus sign. Other than P and VC, no other force is there, right? Moment due to no other force can be generated. If we see point B, so force VB force is there, but there is no distance between B and BB. Similarly for force HB also. Okay, so the total moment will be 0, and here we can find the value of VC as P. So we get the value of VC as P here. Okay, now we can put the value of VC in this equation 1, and we can find the value of VB. So let us put it here. So the equation we got was VB plus VC equal to P, and another equation we got was VC equal to P. From 1 and 2, we can say that VB is equal to 0, right? If we see these two equations, then we can say that VB equal to 0. So now out of all the forces, we get the value of VB and we get the value of VC. Now the only thing remaining is HB force. Okay, to find out HB, we will use the equilibrium equation as summation of force in horizontal direction to be 0. So what are all the forces acting in the horizontal direction? Only this HB. Other than HB, no other force is acting in the horizontal direction. Therefore, we can write as HB equal to 0. Very, very simple question. So, within few seconds, we got the value of VB, VC and HB. So, the VB we were getting as 0, HB we were getting as 0, and VC we were getting as P. So, the option will be option number A here. VB equal to 0, HB equal to 0 and VC equal to P. Okay, for a determinate truss, if you are asked to find out the reactions only, then there is no need to analyze the forces in each and every member. You should just use the equilibrium equation for a determinate truss. Okay, you do not have to find what are the forces due to this externally applied load P and all. You do not need to worry about what is happening inside the truss. You just have to use the equilibrium equation and get the answer. Okay, I hope it is clear. Are there any doubts? If not, I'll proceed. Okay. If there are any doubts, you can ask me and stop me and ask me. Now we will see another question here. Yeah, so it is a GATE 2018 set 2. So in this question, it is a planar truss which is given, which has same properties in terms of area and modulus of elasticity. So they are asking, for the loads acting on the truss, the statement that correctly represents the nature of force in the member of truss. So basically, they are asking to analyze this truss, that is, to find the forces in different members of the truss. Okay, so it's a very simple question, but yeah, you should know how to. So first of all, let us for finding out the forces in different members, the first step will be to find out the reactions. Okay, the first step should be the finding out the reactions. So let us see what are all the reactions. So let us name this joint as B and this as A, let's say. Okay, so A, this is A, this is B. So what are all the reactions acting on this joint B? It will be horizontal B, HB, and vertical B. Okay, since it was a hinge support, so therefore two reactions. Okay, at A also, this vertical A and this horizontal A. Okay, so we have marked the reactions. Then we will see what is the value of these reactions. So this was the externally applied load P. So if you see the total equilibrium, so this HB, so if we see that summation of force in horizontal direction to be 0, so this is the applied load P here, therefore this HB has to be P in order to balance it. Similarly, this is P here, applied load P, so in order to balance the horizontal equilibrium, it has to be P here. Okay, and this is also balancing the total horizontal equilibrium. If you see the right side, so what are all the forces in the horizontal direction? This P external load P, this is HB, so minus HB, this is HA plus HA, so I'm not putting the values yet, and this is minus P equal to 0. It should be 0. Okay, so let's see. Now put the value of HB and HA also here, so minus P plus P and minus P. So total force in the horizontal direction should be 0, and it is coming out to be 0 as well. Okay, yeah, so if it is the applied load P here, this horizontal reaction has to be P only. Since here it is also P, it should be P here. Okay, so equation we know now the value of horizontal reaction. So what will be the vertical reaction? Is there any external load which is applied in the vertical direction? No, right? If I'll remove everything, there is no external load which is applied in the vertical direction. Therefore, reaction will be 0 in the vertical direction for both the cases. Okay, so whenever you get this type of question in which you have to find the forces in different members, so first step is to find out the reaction. So after finding out the reaction, you should proceed further then. Okay, the next step is to find the forces. So another thing you should keep in mind, that if you have this kind of case in which there's a load, external load, which is applied in line to any member. For example, this load P was acting in line with this member AP. So whenever there's this case, then the entire load get transferred to that particular member only. For example, here's a applied load P here. So the member AP will take the entire load, and the force in member AP will be P. I'll give you an example. Uh, For example, if it is a truss, we have, okay. So what I was saying, ki if you have this A, B, C, D, and at this node B, if you have any vertical load applied. So if you have any vertical load P applied, which is in line with this member BC, so the member BC will take the entire P load. So the force in member BC will be P only, and the other member which is connected to it will be zero force member. So that is the thing you have to keep in mind. Okay, if any external load which is acting on a joint is in line with that member and the other member is perpendicular to it, so this member will take the entire load and the other member will become a zero force member. Okay, so these small things, first thing is the identifying the zero force member, that will help you a lot in truss analysis, and second, this kind of small things we have to keep in mind. Now we if we see this load also, this load P is also in line with the member PB, so it will take the entire load P. Okay, and of course you should keep this thing in also in mind, that if this load P is in this direction, so this load in the member, the force in this joint will be like this. Okay, and it will be P only, and the other member which is connected to it will become a zero force member. Is it clear? Any doubt in this? So with this thing you should keep in mind, and this we will consider as, this is a tensile force. Okay, I hope you know this thing. Okay, so this force which we show in this members now, this is actually the force in the at the joints. If the force at the joint is in this direction, so this, then the force in the member will be compression. Okay, sorry, will be tension. Okay, so whenever we draw this kind of force in a member, this means this looks like compression, but it is a tensile force. Okay, because we are showing this force in the for the joints. Okay, just remember this thing. You can ask me, okay, because I'm just speaking, I don't know what you are understanding or not. If you have any doubt, please ask me. Okay, yeah, I have should have told you this thing before actually. So whenever we are analyzing a truss na, so let's see, say it's a truss here. So whenever we are analyzing a truss, so we whenever we are marking the forces in it, so we initially we consider force in every member to be tensile, because we consider tension as positive. So whenever we mark tension, so we mark the tensile force like this. Why we mark the but it looks like compressive, like sign is looking like compressive force, but it is a tensile force. Why it is a tensile force, I'll tell you. Because this force which we are showing is are not the member forces, these are forces at the joints. So the member forces will be opposite to those that which are acting at the joint. For example, yeah, so if we look at this joint, let's say joint number A. So for this joint, we'll say that this is a joint AB, right? So for this joint, we are like these forces, the joint A forces, A at A and B are looking like compressive force, but when they are, it is transferring to this member, for the member it is tensile force. Okay, so just remember this, that whenever we are marking the forces, we have to mark the tensile force like this, although it looks like compressive, but it is a tensile force. Okay, just remember this thing. Okay, so now we have found out the forces in all the members except this member AB. Okay, so the member AB, yeah, we have this applied load P, and this member PB is taking all the force. This member is also a zero force member. This member will also be a zero force member, and this member will also be a zero force member in this case. Because if you analyze this joint B, so this joint, this member AB, sorry, PB is taking all the load P, and these two members will then become a zero force member. Okay, so in this question we were just they are asking us the forces in all the members. Okay, so the first option is there are three members in tension and two members in compression. But and the second option is there are two members in tension and two members in compression, and one is a zero force member. But we got the answer as, we have two members in tension and three as zero force member. So the answer will be option number D in this case. Okay, I think I have not explained it correctly. Okay, let's do it again. So in this question, the first step you should keep in mind that whenever you are asked to find the forces in the members, you should first find out the reactions. Okay. The second thing you should see that what members are the zero force members. Okay, so that you can identify using the concept which I have discussed earlier. In this thing, the main concept which I was trying to tell you is that this one, whenever a load is acting at a joint and the other member is in line with that joint, then the entire force will be taken by that particular joint. So that is an important point for this question. So using that concept, we got to know that if this load is acting here, so this member PB will take the entire load P, and other members will become a zero force member. Why? Because then if the entire load is taken by PB, the other member will not take any force, right? So this member will become a zero force member. Similarly, for this case also, this member will take the entire load P, and the other member will become a zero force member. So the entire load which is acting on the this truss was P. So this member has taken the P load, this member has taken this P load. So this member is also zero force member in this case. So they were just asking which members are zero force member and which members are taking the forces, and if yes, then what is the type of that force, tensile force or compressive force. Okay, I hope it should be clear, but if not, then you can ask me again. Otherwise, I'll move to next question. What is the time now? Just read it once again, okay, this thing. And if you could not solve any question using this, then we'll discuss again. Okay, and this particular thing, please keep in mind that this force is a tensile force, because this force is the force which we are marking this is the force is acting on the joint, not on the member. So when whatever is the sign of the force which is acting on a joint, the member will take the opposite of it. Okay, in the free body diagram. Therefore this sign we will consider as a tensile sign, not a compressive sign. Okay. Yeah, so again a complicated looking problem, but not that difficult. Okay, so in this question, the plane truss has hinge support at P and W, which is subjected to horizontal force as shown in the figure. Okay, so before discussing it, let us see one more question of the zero force member, so that it will not be a uh, burden for you. So let's solve this quick question. Please try this question once. Okay, so using the concept of zero force member, then I'll continue with that gate 2020 question. Please try this. Let's see how many zero force member you are able to identify. You can write in the comments whatever member is a zero force member, you can write. Please practice, otherwise you will not get anything out of this. Whatever member you are getting, just write in the comment. Not a single one till now. Should I do it? Great. Harini is saying GB, which is right. GBBI, which is also right. MJ is also correct. And HE is also correct. So what about member IJ? IJ will also be a zero force member, right? Because now MJ is a zero force member, so IJ will also be a zero force member, right? So you see, using this method you can quickly identify the zero force member. Will this OR be a zero force member or not? OR, is OR a zero force member? Yes, right, because OR, this CR and RD are in line with each other. There is no external load acting on it. So therefore, this is also a zero force member. Okay. So there are these simple things. This is KN a zero force member? KN, please write yes or no. Can satisfy all the conditions of zero force member. It has maximum three members which are connected to it. Okay, and out of the three members, two are in line with each other. But the only problem here is this external load P, 2P, which should not be acting if this member Kn has to be a zero force member. Okay, so in this way, you can easily identify the zero force member. Okay, so this was just to make the things little bit lighter. Now we'll continue with our question. So this is a GATE 2020 question set 2. Okay, so there's a plain truss uh, that has hinge support at P and W, which is subjected to horizontal forces as shown in the figure. Okay, so representing tensile force with positive sign and compressive force with negative sign, the force in member XW is. So they are asking the force in this member. Okay, so if they are asking force in one particular member for a very big truss, so you should know at that particular point that you have doubt. What doubt in which question? Uh, this zero force member question, Rahul? No. Okay. Okay, so if you have doubt, you can ask me. Okay, this current question. So yeah, I'm just discussing it. Yeah, so I'm discussing it, then you can discuss the doubts as well. So whatever is the doubt, you can write. Okay. So where were we? So whenever there's a big truss in which you have to find force in one particular member, then you should use the method of sections. Okay, you cannot analyze each and every joint. Okay, so that is the idea. So in this big truss, you have to find the force in only one member, so that you have to use the method of sections. So you have to cut the truss in such a way that that particular member, here in this case xw, should be the force should be that member should be in the section. Okay, so how to cut this section now? So we have to find the force in member xw. So what should we do? We have to cut this section. We have to cut a section and find the forces in different. Yeah, so let's cut it like this. Okay, after cutting, let us draw also, right, how the section looks like now. So after cutting, the section looks like this. Just tell me if I'm wrong. This is the thing. And after making that section, let's expose all the forces right now. Okay, so there is a 10 kilonewton load here. There is a 10 kilonewton load here also. There is a 10 kilonewton load. So when after cutting the section, we have to make the released forces also, right? So now we have cut this section QT, right? So there should be like FQT. We have cut this member QP also, right? So there should be FQP. What are the member we cut? This member TX also, right? So it should be FTX. What else? Yeah, this are FXW. We do not need to make this below part. If you want, we can make. Okay, but we do not require here. So we have cut the section. And after cutting, we have shown all the forces which are released after cutting. So is it okay? This thing should be fine, right? I just cut this section, and wherever I cut this section, for example, I cut this section at QP, so I wrote FQP. I released this force FQP. I cut this section QT, so I released FQT. And I cut here. We made a cut. Why we use summation of MP0? Where? Till now I haven't done anything, right? Why we wouldn't use summation of MP? Acha, why we are not using? Because till now, like if we use MP, na, it's like if we use, you're saying why we are not using MP to be zero, but that equation summation of MP equal to zero will only help us in identifying the reactions, not the internal forces. To find out the internal forces, that is a force in any particular member, we have to cut the section first, so that this force, the required force, is exposed. And after cutting the section, then we will use the equilibrium equations. We will not use the equilibrium equations before, because using the equilibrium equation before cutting the section will only help us in finding out the reactions. Suppose we need to find out the reaction VW or HW or anything else, then we would have when then we do not require to cut the section. Here they are not asking the reactions, they are asking the force in any particular member. So like in this previous question, they were asking, which question was here? In this question, they were asking the reaction. So therefore, we did not cut any section. We just simply use the equilibrium equation to find the reaction. But in this particular question, they are asking what is the force in member XW. So whenever there's a big truss and they are asking force in one particular member, then you should use the method of section. To use the method of section, first you should the reaction support RW will also cause the force. Yeah, that will also, but that the method what you are suggesting, it's the method of joints. You are saying that first we find out the reaction at every possible reaction, then we move joint wise and see analyze the different members. That is the method of joints, but that will become very lengthy for this type of huge truss. Therefore, to make it easy, we are using the method of sections here. The whatever you are saying, you can try to do that. You'll find that since there are lot of members here, so you have to do a lot of analysis. Okay, so for making the thing simpler, we can use the method of section. And while using the method of section, you should cut that particular section. You should make sure that that particular section is we are cutting, in which we have to find out the forces. I hope it is clear. So, okay, so in method of section, you do not need to find out the reactions also. Okay. So what did I do? I just cut this section like this, so that all the, especially this XW, should be exposed. And then after cutting the section, I showed the all the forces which are released. Let us see, this is 4 meter distance, this is also 4 meter distance, this is 2 meter distance, and this is 2 meter distance. So I hope it is clear ki why I cut the section. I cut the section in order to expose this force Fxw. This is the method of sections. Okay. After cutting the section and after drawing this free body diagram, what we will do now, we will use the equilibrium equation. We will take the moment, summation of moment about this point Q. Why? Because we can take this also, but we need to find Fxw. Therefore, we are taking the moment about this point Q. So we'll take the moment about Q, summation of moment at Q to be 0. So we will use that equilibrium equation to be 0. So what are all the let me make it here. I don't know whether it will come or not. Yeah, okay. Yeah, so we will use this equilibrium equation, summation of moment at Q to be 0. Let's see what are all the forces. So now we are taking moment about this point. Just remember what are all the forces I'm taking. So now what are the forces? So F xw, let's say fxw first, fxw multiplied by the distance. So the distance between this point q and this fxw is 4 meter, right? What is the other force which is acting? Ftx is also there, but the distance between this point q and the line of action of ftx, which is this is the line of action of ftx, right? So this is 0, so the entire term will become 0. Other than fxw and ftx, what are the forces that are acting? This 10 and this 10, right? So this 10 we will take first. So it will be plus 10 multiplied by the distance between 10, this force, line of action of this force, and the point q is, this distance is 8, right? 8 meter. Now we'll take this 10 kilonewton force. So again it is in the same direction, so plus 10. And what is the distance between this line of action of this load and the point, this q? So it is 4 meter. Other than that, is there any other force? Okay, just let me finish and then I'll tell you. So equal to 0. Other than fxw, this 10 kilonewton here and this 10 kilonewton here, there is no other force. Okay, is there any other force? This 10 is also there, but there is no distance between 10 and q, right? So fxw will be 80, let's say minus sign, 80 plus 40 divided by 4, right? So fxw we are getting as minus 120 divided by 4. So fxw we get as minus 30 kilometer. Is there any doubt in this question? Okay, so why we sometimes we are why we 30 towards the joint, huh? What is whatever the direction we have assumed from, so in this thing we have assumed the direction to be fxw to be away from the joint. If we are getting the negative thing, then it means that this assumed direction is opposite to it. Okay, so the actual thing will be, but we do not need to worry about it. We just want to know the reaction here. So it sorry, force here. So it was minus 30 kilonewton. So it is minus 30 is the answer. Okay, so the point of telling you this question is that why, when we should use the method of joint and when we should use the method of section. Okay, method of joint we should use whenever the truss is very small. Okay, so that particular truss can be analyzed using methods of joint, my method of joints. And for method of section, you should choose this method only when there's a huge truss and they're asking you to find the reaction in one particular member. So in that case, this method will become easier. Okay, you just need to cut the section and use the equations of equilibrium. Thank you, Rahul. Any question? I hope time is over, right? Yeah, so regarding doubts, I have no such platform in which you can ask me doubts. Yeah, but if there's a particular question topic which you want me to cover, then you can write it in the comments. So the next section, in the next class, I'll take that particular topic, and in that particular topic, you can ask me any doubts. You can try to solve questions using for that particular topic, and if there are any doubts, you can ask me questions. So yes, if you want to learn one particular topic, then you can write in the this comment section, and I'll take up that particular topic only in the coming sections. Okay, is there any doubt? Please, yeah, please, you should interact, because if you were at my place, then I'm just speaking in front of screen. I don't know whether I can't even see your faces, right? So I don't know how you are understanding or not. So please respond whenever I'm asking. And in this topic, particularly particularly for structures, you should solve the questions when I'm solving it. You should also solve. Okay, then you'll get to know that where you are stucking. Okay. Okay, then I think it's okay for today. And yeah, LinkedIn mein questions. It'll be difficult for me to answer questions in LinkedIn. Okay, just try. If you have any particular topic, please come write in the comment, and I'll take up that topic in the next question. And you can ask me as many questions in the class. Okay. Okay, then thank you so much for today. I'm recording. Yeah, Harini, you want to ask something? Yeah, ठीक है. There's no particular rule that how to cut the sections. The one thing you should keep in mind, that after cutting the section, so if you'll practice now, you'll get to know how to cut the section. But one thing you should keep in mind, that you should cut the section in such a way that the particular member in which you have to find the force, that should be coming in the path. Okay, otherwise there is no use of cutting the section. If you would cut the section here, then there's of no use for you, right? Because you have to find the force in member xw. And other than that, there's no hard and fast rule, but after cutting the section, you should be able to find out the forces. For example, if this truss would have some different shape, like this members would be like this, something like this, then what would happen now, the problem that you might uh, get, that I'm discussing, then you will get the forces, which the released forces, like this. Let's say fx and fy, if this shape would be like this of truss, है ना? Then what would happen, even if you use the equilibrium equation now, so number of unknowns will become more, and you won't be able to find the value of x fxw. Okay, so you should like in this question there was no problem, but in some other question you should cut a section in such a way that after cutting the section, the number of unknown forces should not be too much. Okay, in this case there is no problem. For that you should practice some more. So you should see some more questions from this method of section, and see after cutting the section whether the number of unknowns are in limit or not. Because if the number of unknowns is, for example in this case, the number of unknowns are too much, even if you use that moment about q to be 0 now, then you won't be able to find out this value of fxw, because you don't know fx also and you don't know fy also. Okay, so these things are very important for methods of section, for method of sections. But they won't give you any such question that you won't be able to solve using this thing also. So but if you want to know, then you should practice some more questions, then you'll get to know how to cut the section. The main thing, that particular member in which you have to find the force should be in the path. And the second thing is, you are not cutting the section in such a way that there are too many unknowns that you can't solve then. For example, if you would have cut the section in this way na, then there would be a problem. Then this force unknown, then what would happen na, this would be the force, and this would be the released force, this would be the released force, and then you can't find the value of fxw. Okay, so you have to choose a section wisely. Okay, so for that you have to practice. Okay, that is the only way. I hope it is clear now, right, Harini? Oh, thank you. Thank you for listening, everyone. Okay, then bye.